Software design faces a persistent bottleneck, getting raw data out of a user's brain and into a structured database. Traditional SaaS platforms brute force this problem. They require users to learn proprietary interfaces, navigate unfamiliar dashboards, and fill out tedious manual forms. But an alternative exists in headless architectures, which bypass proprietary front-ends entirely to collect data where the user is already working. This diagram illustrates exactly how such a bypass functions. Looking at the left panel in box 1, we see the ingestion point for this entire architecture, a standard Google Calendar interface. It contains the standard elements you are already accustomed to creating, an event title like Philadelphia Phillies versus San Francisco Giants, paired with a date and a time block. The exploit used to extract data from this standard interface relies entirely on the guest list. By inputting one specific service email address, create@calendarswag.com, the user activates the ingestion trigger for the entire system. The psychology here is highly intentional. The user performs a native scheduling action they already know how to do, requiring zero onboarding or training. Yet hitting save triggers an invisible payload, silently pushing that schedule data to a remote server. This works because calendar clients universally adhere to strict underlying communication standards. Specifically, they use SMTP to route the message and the iCal format to package the schedule data, serving as a highly reliable delivery mechanism for the headless payload. Ultimately, the most frictionless user interface is often one the user doesn't even realize is connected to a larger software ecosystem. Once the user clicks Save, the perspective shifts from the front-end calendar to the back-end infrastructure receiving the data. This introduces an immediate architectural flaw. Using email for data ingestion is difficult because emails are inherently stateless. An email is a one-time, isolated message. It drops off its payload and terminates, rather than holding open a continuous connection to a database. Looking at the transition bridging the first two boxes, we can trace how the system captures this isolated payload. The exact ingestion point catching the data is AWS Simple Email Service, or SES. Here, SES is configured strictly as a rigid data mailbox, completely stripping away its standard communication features. Landing in this mailbox, an automated ETL pipeline takes over. It identifies the payload as a brand new event, stored as a new event in the DB. To track this permanently, the system assigns a UID based on the organizer's email. In relational databases, a unique identifier, or UID, is a specific alphanumeric string that guarantees no two records are ever confused. By generating this string, the architecture creates a permanent hard link between the external organizer and the internal system. Through this automated ETL processing, a transient stateless email is successfully anchored as a permanent relational database record. But event scheduling is rarely static. Dates, times, and locations change constantly. This poses a strict engineering challenge. How do you update a specific existing database record when your only input method relies on receiving new, separate emails? From the user's perspective, the action remains identical. They open their native calendar client, make their changes, and click Edit and Save. Returning to the visual pathways on our diagram, we can see how the system routes these secondary actions. Saving an edit generates an entirely new email payload, which follows these update and delete arrows straight into the SES mailbox. To parse this update, the system extracts the UID from the new payload's metadata. It checks this string against a list of pre-existing UUIDs. Finding a match prevents duplication. Instead, the fresh payload overwrites the previous details, updating the record. This establishes a complete CRUD pipeline, meaning the system can create, read, update, and delete data solely through remote email triggers. This pipeline also has to handle edge cases, specifically when a user cancels an event entirely. As noted in the diagram's documentation, there is a strict data retention rule. The system never actually deletes the row. It simply updates the status and marks it as canceled. With this logic in place, the architecture achieves full database mutability without ever exposing a back-end interface to the end user. At this point, the raw calendar metadata has been fully transformed into a clean, mutable, and relational database format. The data is now completely decoupled. It is entirely divorced from its origins in Google Calendar. To put this clean data to use, we need a mechanism to retrieve it from the AWS backend. That retrieval relies on REST APIs, which serve as standardized bridges allowing any external application to query the database. The final destination is the Marketing Hub in Box 3. This presentation layer uses the API to drive automated outputs, generating list-based event feeds, standalone landing pages for each entry, and embedded calls to action for external marketing software. The polished, automated UI components generated here stand in sharp contrast to the raw, manual text input that started the process back in the calendar client. The entire workflow minimizes human friction while maximizing data utility. By combining headless ingestion protocols with strict back-end state management, developers can build massively scalable SaaS tools driven by the simplest, most ubiquitous user actions imaginable.